welcome back to the Tin Barn. I'm Pragmatic Lee, and earlier this week, well actually it was I think a week ago today, I received a package from one of my viewers that requested to remain anonymous. I had been in contact with him, or the viewer had been in contact with me, and got some information from him. And the package came last week. It was a direct ship, but it's kind of a nice little package, I think. This was in it, 2-axis DRO, a 700 millimeter, about, what's that, about 39 or 36 inch, something like that. 150 millimeter scales, some mounting hardware, of course, screws, nut bolts, couple brackets. Of course, we all know in mounting DROs, it's going to take some custom-made brackets as well, and of course shields to go over them. Now this is going to go on my lathe, and I've already got DRO on the lathe. I've got the using the Touch DRO software on an Android tablet with a blue DRO interface module. I've got an earlier video I did on installing that blue DRO module. Take a look at that if you haven't seen it. I haven't had any problems whatsoever with the blue DRO. Al is a good it's a good tool. It has worked good for me. The only thing that's ever happened with it, I had a lightning strike out here that got a little wall brick power supply, but they're $2 or $3 a piece. I threw it in the trash and got another one. The only problem I've had at all with the setup is in the scales, the eye gauging scales. I've got a drawer full of them down there. Well, not full, I've got 6 or 8 of them down there that has just given out over the last couple of years. They don't seem to hold up that well. I am definitely a hobbyist, but I'm out here in the Tin Barn at least 4 days a week, and I would say my lathe gets run time, I'm going to estimate 10 to 15 hours a week, just projects. And the eye gauging scales, while they work good, they seem to repeat well, they just don't hold up to any coolant whatsoever, or even cutting oil if you get on much cutting oil on them. Several times I've taken the scales off, oiled them, or cleaned them up, removed the oil off of them, and they'd work again for a while. But this video is not about that setup. Again, the blue DRO, the iTouch software, the Android tablets have worked great. Maybe a different type of scale on there. But the viewer sent me this, and I'm going to install that, and I'm not going to show you, and I'm not going to try to bore you with every time I drill a hole in there to mount this. There are dozens, if not 100 more videos on YouTube of installing DROs. And it's pretty much the same thing, finding the right spot, drilling the holes, lining up the reader and the scales, and screwing everything down is basically what it amounts to. So I'm going to take a few shots along during the way to show you the process. There won't be any machining in this video, but maybe you'll learn a little something from it. And I have powered this up, and it's currently set up for a mill. I will be setting this up for a lathe, which basically means the x-axis will read diameter change and not radius change. Let me swing the camera around and show you my current lathe setup. This is the Android tablet up here. The blue DRO interface is mounted on this post around back here. The scales right now are mounted, of course, on the back here for the Z-axis. The X-axis is mounted behind, hanging off, suspended off behind the carriage. I've had a lot of inquiries about that over the years in videos, and I'm going to show you some more detail on how I do that. And when I get the back cover off and get the camera a little bit closer, I'll also explain to you why I'm not mounting it over here nor mounting it on this side. So first thing I need to do is clean off my workbench and get all my tool holders over here placed in order. Sometimes I'm so OCD that I'm OCD about my OCD. But I've got these in an order now that's in my brain. I know where to reach for if I want the threading tool or the parting tool, the inside threading, the knurling, and so forth. So I'm going to take a couple pictures of this. Then I'm going to unload this, take this back off. I've got a pallet jack over here. I'm going to set everything up, or lift everything up, set it out here where I can get to the back, and then I'll get you some better shots of the progress as we go along. Okay, here's a shot of the back side of the lathe now with all the eye gauging scales taken off. This lathe actually has a boss plate part of the casting here where a combination lathe mill could be done on this base here. I don't think Precision Matthews sells one, but I'm sure this base is used on other lathes as well. The scale I'm going to mount back here. As it turns out, there's a boss down here at this end and up here at the motor end that is same distance out. So I'm going to drill and tap in these. I'll find a reasonable height here. Mount this. This will be the easiest one right here to mount. And then for the reader, I'm going to put the wires running out in this direction. That way I can come closer up here. My compound is slid as close to the spindle headstock as it can get right now. So with the cables wiring coming out that side, I should be able to slide all the way up here without any problem. And of course I can't slide any past the tailstock down here on this end anyhow. So I'm going to start work on mounting this, then I'll bring you back when I get something worked out. One more thing I wanted to do before I start putting the scales on the back of this. Over here in this back corner, I'm going to drill and tap for a 1/4 inch NPT fitting. Put a drain in there, draining this pan. I tried to use a mister with eye gauging scales on there, and it just, after just a few minutes, they would start to jump and just erratic readings. The type of scales that I'm putting on here now, I've got on the mill as well, and practically 2 years using them over there, and have never had an issue with the scales malfunctioning due to the mister over there. So I'm going to drill and tap for a 1/4 inch NPT fitting back here in this back corner. I've got the drain hole drilled and tapped over here in the table. What I'll have to do is mix up a little epoxy and put around and seal that edge between the drip pan and the table itself. But that should provide me a good drain there. I'll just have a piece of hose out the bottom. Also got the scale mounted on the back now. This was a simple mount. It was just drill and tap a hole down here, drill and tap one down here. The hardest part of this whole thing was the tap handle, having to slide the T part of it back and forth to clear the motor. Very, very simple installation back here. On this, I already had a couple holes drilled in the carriage plate here, but I use those, just a piece of flat bar. The reader on the scales itself is actually threaded. Let me grab the other one. These are threaded with a 5mm .8 thread. So simply, to keep that rigid, keep it level, I run a 5mm screw through this plate that I made. This is some hardware mounting hardware comes with it, but chances of it working in your situation are probably slim and none. But I just made a little plate out of this 3" by 1/8 flat bar, cut it to approximate length, put some slots in and so forth. Run that screw in, and then on the back side of this screw right here, there is a nut and washer. So this is held solid. And as I move the carriage, of course I've checked for clearance all the way around, but that travels. To get the scales itself level and plane, measured from this machine surface here to measured there and here, and got that the same. Then this, just use some to be sure that was level in there. This will hook to the reader head, to the head when it's hooked up. Now I'm going to move the camera around and where you can see the cross slide and the carriage a little better. Before I do that though, there is one more piece on the back, and that's simply this guard here. And remember I said there was 3 bosses on here. There's the one up here if it was a mill combination, and on each end that we screwed in. So where this needs to attach, I cut some simple little spacer blocks. And I've got 3 holes drilled and tapped back here for those. No real special measurement on these. It's just a matter of getting it where it's not rubbing against the head and not interfering with any of your mounting hardware. So I'm going to get that on, and then like I say, I'll bring the camera around and we'll talk about how I'm going to mount the scales for the X-axis. Okay, I think we're ready to install the X-axis scale now, but before I do, I want to go over a little bit of the reason why I'm doing this pretty much different than anyone else I've seen put a DRO on a lathe. Some people will mount them on this side of the carriage. The problem with that though is there's just not that much clearance. It would also take up whatever the thickness of the guard. Well, the whole thing is going to be, the shield and everything on it, at least 1.5 inches of travel that I would lose out of my carriage if that was sitting there. Another issue with it being over here, my gib adjustment screws are on this side. Now, I don't want to block them. I've got oilers right here. I don't want to block those. I have seen people mount them on this side. As you can see now, I've got to chuck off. I use the back plate a lot, and the back plate requires that I get the carriage up as close as possible to the back plate to work the work that's mounted on there. Plus, with the chuck out here, if I tried to mount it on this side, the problems here is, again, the space, just not a lot of space. 2 oilers over here. The mounting holes for the follow rest are down here, and it would be in the way of the chuck. I would not be able to go up any further. I would not be able to go under the chuck, basically. So And looking at all that, you know, sometimes you got to get kind of pragmatic when you come up with a situation like this. Think it through, look at your other alternatives. What I'm going to do is mount this suspended off of the back of the carriage. It'll be braced well. Now, before I lose any of you that say, well, my chip guard back there is not deep enough to put a scale on that I could get the full travel on. Well, mine's not either. I'm going to come up about 2 inches short back here. But I'm going to put that chip guard back on there, and the rack I had on the top up here for the tool holders. But that'll be just a little bit later. But just don't leave me now because you think it's not going to work on yours. Again, got to be a little bit pragmatic about it. So what we're going to do first, what I've got is a piece of 1.5 inch angle here, aluminum angle. I drilled and tapped 2 holes right here in the carriage. I did not go all the way through. I didn't want to get on my ways, didn't want the dust to go in there either. I also drilled a clearance hole here for that oiler that's right there. So let's get this piece mounted on. All right, I'm leaving that a little bit loose right now. Over here in this plate that we mounted for the Z-axis, also made it just a little L bracket. Now, to make this rigid, I'm going to use a piece of 1/8 inch by 3/4 inch wide flat bar. There's not going to be any pressure on this, so it doesn't have to be hard steel or anything like that. We'll mount this in. Hope I'm not completely in the way here. Again, I'm going to leave it a little bit loose right now. It's nothing more than a piece of scrap I had over in my bin that already had a hole drilled in it. Just cut it to length. Now I'm going to snug all the fasteners up just a little. Okay, that's about 10 thousandths off right now. May have got it a little too far. Let's see. All right, that's about 3 thousandths there. You know, let's put that in perspective. That's less than a human hair. So I think that will be just fine. Let me turn it around. Maybe you can see that. Point of the needle is right here. Let's see how well that stays. All right, that's about 5 thousandths over. Again, that is perfectly fine for what we're doing at this point. So now we got something to mount our scales on here. Let me back the cross slide back out of the way. Our scale is going to mount on this side. And just like I did down here on the Z-axis scale, remember this piece is threaded. So I use some 5mm threaded rod, and I'm going to go ahead and mount those in there. I found as I was putting this together, I needed to space this off just a little bit off of this because there's a lip right here I needed to get beyond. So I'm using just a couple washers for spacers right there. All right, this end is resting on that lip that I was talking about there. So I'm going to go ahead and snug this end down. get a visual on that to begin with. All right, that's on 0 now. Again, that's within 3 thousandths. Please take my word for it. I've got no reason to try to boo-hoo you or hoodoo you. But that's within 3 thousandths. That is plenty good. That's, again, less than a hair for those of you that's got hair. Now we need to tie the reader to the carriage as it's sliding back and forth. So all I've got here is just a simple plate that's this looks like 3/16 that will span across those pieces of threaded 5mm threaded rod that I put in there. And just like on the Z-axis, this has a nut on each side of the plate. This makes it rigid, with it being a nut on each side of the plate and the reader itself being threaded. This end is going to be rigid. Now in the cross slide up here, I put a T-nut in, made a little T-nut that fits this. This is nothing more than a 1/2 inch by 1.5 inch flat bar. It's got 2 threaded holes in it to match this arm right here. Now, I'm sure everybody understands, but all these pieces didn't just happen into place. It took a lot of measuring, took a little bit of trial and error. So far I didn't drill but 1 hole in the wrong place. That was in this piece of aluminum here to mount this scale on. I was 1/4 inch off. And I cut this piece too short to begin with because I didn't have my carriage all the way back against the stop. Now with this in place, don't know whether you saw it or not, but this piece right here actually has a lip milled into it. It actually turned out to be 300 thousandths deep to bring this out flush over here and just basically make everything line up. And all I'm doing there, we made certain this was parallel with the cross slide. We made sure it was level. Now I want to make sure that the reader is riding parallel with the with this angle as well. So that's got this mounted. The only thing that's left is the protective cover plate over here. Okay, give me a moment to get the scales hooked up to the head, and we'll see if all this works. All right, I've got the DRO head just sitting here on the end of the table. Got both axes zeroed out. Of course, most of the DRO manufacturers assume that these are going on mills, and they label X and Y. This is going to be X and Z, of course. I've got a label maker. I'll just cover that up, the Y up, and put a Z there. But let's see what we got for movement. I've got approximately 6 inches of travel on my cross slide. Almost 6 1/4. 6.14. Okay, I've got to get, yeah, that direction is correct on that. That shows negative. It's displaying 5 decimal places now. Hopefully I can narrow that down. Are we seeing movement? All right, let's zero out the Z now. Ooh, looks like a storm's coming up. My door just blew open. Okay, we've got some movement there. But I'm gonna start working on now my modification to the chip guard back here, and I'll bring you back when I get that done. I've got the backsplash, if you will, mounted back on the lathe now. Before I started this project, I measured from the back of the waves right here to the backsplash or chip guard, chip pan, measured that distance. After mounting the DRO suspended off the back here, I measured the space that I would need to clear this backsplash when I put it back on. The difference in that was about 3 inches, but I decided I'd go ahead and give myself plenty of room. I like this extra room, reaching in here, getting chips out, cleaning up in here and all. It was a somewhat of a tight fit before to get around in there and clean up. So instead of just 3 inches, I decided I'd add 4.5 inches. That gives me plenty of room in here to reach in. These were the 3 mounting holes to begin with. I measured 4.5 inches over, and of course got the holes in line. This is the electrical panel box back here, and of course it goes without saying, but I verified, took the cover off, verified that I was not going to drill into anything back there. I had plenty of clearance, so I drilled and tapped 3 holes here. That took care of that end. Down here on the other end, I drilled and tapped a couple of holes here. This before had a lip that turned 90 degrees and bolted up to the back of this. I just straightened that L bracket out, drilled and tapped 2 holes over here, then drilled 2 holes in both, or drilled 2 holes in the addition plate to match up with the L bracket and put that on. Now also, before I started this project, I realized that I was going to have to move this backsplash back. Knew that to begin with. So I went around back and put a Sharpie mark inside this clearance housing here for the motor. Then with the help of a little CAD, some cardboard aided design here, I made just a little piece to go down in here to cover that, to protect the motor. The motor is right behind back here, and so this set back further, I needed a little housing to clear there. So I'm not sure how well you can see that, but I also made certain around back that I had plenty of vent space so that the motor could get air. So now what I'm going to do is mount my shelf that I had before. Going to mount that on here, get that set up, get my tool holders, or get the lathe back in place, get my tool holders on, then we'll put the head on. One thing also I didn't show you, let me move the camera. Put a hole through the back and a cover plate on there to secure the cables. But that's the cables going out here, and I got all the extra here that I'll pull around to the head once I get that mounted. And of course, there's one more thing. I always say one more thing, but there was another item here that I didn't show you. But with the backsplash being back 4.5 inches, that left a gap here between the drip pan and the backsplash. So I just went to Lowe's and picked up a couple 22 gauge pieces of 6x24 sheet metal and got those screwed down in there, keep the chips from falling between the backsplash and the chip pan. Okay, I think we're ready to wrap this video up. The scales are installed now. I've got the display head mounted. I've got my shelf back on the backsplash. All my tool holders are in place just like it was. I'm really liking this extra space back here already, regardless of the DRO. I like this extra space back here. It'd be much easier to get in here clean out chips, and just keep the lathe overall cleaned up a little easier. There's a couple, well actually 3 parameters on this DRO that I'd like to try to change. First one deals with the cross slide feed direction, or cross slide readings, excuse me. If I set my manual dial to 0 right now, 0 out X, if I move the dial 20 thousandths, my display is reading 10 thousandths. That's because the display now is reading against the radius of the work material and not the diameter. On a mill, obviously you want it to read exactly what you're going in. On a lathe, you want it to read double what you're going in because you're taking that much off the diameter. So we want to find a parameter that will change this to correspond to what the dial reads, and will tell us exactly what we're taking off the diameter of the piece as we turn. The second thing that I want to do is set my positive and negative directions. The cross slide is correct as I dial in, or is correct for me. As I dial in, I'm positively increasing the number. When I go past 0, coming out, I'm going into a negative. I want my Z-axis, or Y as it's called on the DRO, I want it to read positive as I'm going in, but as you can see now, as I advance toward the headstock, I'm getting a negative value. As I advance toward the tailstock, I'm getting a positive value. I want to reverse that on the Y-axis. Third thing I want to do is try to take away some of these annoying, to me, annoying decimal places. 5 decimal places, I can't touch. I experimented and tried to move the dial enough to advance or increment or decrement this 5th digit. I couldn't do it. I would love to get it down to 3 digits for the kind of work that I do here in the 10 barn. I don't think I'll be able to do that. I think 4 is probably the least amount. But I want to try to change both axes to 4 decimal places on the inches. On the millimeters, that would be 3 decimal places. It's currently 3 decimal places and 5. And I want to decrease that to 3 if possible. So let's look at how you get into the parameters of this. This unit, again, is the JCS900-2AE. JingCE is the way this one's branded. This is marketed or sold on eBay under several different names, and some of the import stores, I think Banggood has this same one. AliExpress, I think, has it as well. This one, according to the viewer that donated it, came through a seller on eBay. If you're interested in that, drop me an email and I'll pass you that information on. I think this whole unit with the scales was about $200. All right, let's look at getting into the parameters. We're going to turn the unit off. Right down here is an S button. You wouldn't really realize there's a button behind there if you didn't run your finger across it. As this is powering up, while it's cycling through, hit that S. Now we're in setting up the parameters. The first one we want to look for, using the down arrows, the XYZ resolution. X is the one that we want to read double whenever we move it. Double from what it is now. They're both set at 5, and I honestly do not know what this 5 represents. But I do know if we go back and change this one to 10, then that will take care of the cross slide as we advance in, reading against the diameter and not the radius. The next one we want to look at is the direction. You've got two choices here, 0 and 1. The Y on here, which is our Z, is what we want to change. So now that should give us a positive number as we're feeding toward the headstock. Third parameter we're looking for is the inch dot. And again, I would like to change that to 3, but it's only going to let me do either 4 or 5. So I'm going to set those to 4. Now, to save all those changes, we hit the S button again. Alright, so let's zero out. Get my dial at a good 0 here. Now, when I roll up 20 on the dial, I've got 20 on the display, exactly what I want. When I feed toward the headstock, I get a positive number here instead of a negative. When I go toward the tailstock, I'm decrementing. Thirdly, I've got 4 decimal places now instead of the 3. Wonder if that changed anything. No, that didn't change anything on the millimeter inch. I suspect if you set that to millimeter and then go into the setup, well, let's try that right quick. It's still showing the inch dot up here on the 4. So I'm not sure if you can change the number of decimal places on when it's set to millimeters. One more thing I want to go over on this before I conclude this video, and it's something I've used on DROs on both the mill and the lathe since I first started this hobby of machining. And I see a lot of other videos, watch a lot of other videos, and very seldom do I see folks using this feature that's built into a DRO. But let's say here on the lathe, we have a piece of stock in here. We make a cut on it. We measure that cut. And let's say, for instance, that cut is 731.731. We want it 5/8, 0.625. Now, what I see so often is folks going to the calculator, subtracting 625 from 731, and getting the difference, and then zeroing out and advancing to that difference. In this case here, let's look at the calculator. 0.731 minus 0.625. I didn't get my minus in there. 0.731 minus 0.625. It's 106 thousandths. So they will come over here and advance, keep cutting in until they get to 106 thousandths, which is perfectly fine if you can remember that 106 thousandths. You can write it down on the top of your cross slide here, top of your compound, whatever works for you. But there is another function in these DROs. The one I had on the lathe before called it a dimension. And if you watch my videos, you've heard me hundreds of times use the term of setting a dimension. In this DRO, it's called a coordinate. We have determined that the difference in what we want between the 731 is what we measured here, and the 625 is what we desired, is a 0.106. So just hit the X here and put our 0.106. Now we want it to be a negative value, so I'm going to hit the plus minus. So now X is set to a coordinate of 0.106. Now all we've got to do, hit the enter key after you transfer it over to, after you set that. Now all we've got to do is keep advancing this until we get to 0. We don't have to remember that 106 in our head, we just go down to 0. I think that's pretty well going to conclude it. Okay, I hope you've enjoyed this video. I'm going to wrap it up at that. As I learn more features of this software, if there's enough of them to put together, I'll put together another video on the various features as I learn them. Take care, and we'll see you on the next one.